So in this video, we are going to be graphing absolute value functions. So we're going to start with a function and graph it. And kind of the process we're going to be using is called transformations or shifts. We're going to do a quick investigation here just to get the basic idea of what the shape of an absolute value function looks like. So here we go. We have f of x equals 2 absolute value of x minus 1 plus 3. So for this row here, we're just going to make a table of values and plot all the points and then figure out the shape from there. For the x is negative 1, we're going to replace the x with a negative 1. So x becomes negative 1. And then we do order of operation or PEMDAS. Now, the absolute value symbols do act as a grouping symbol similar to parentheses. So we're going to start with that. So we're going to start with the grouping symbols, negative 1 minus 1. Well, that's going to make a negative 2. Now, the absolute value of negative 2 is a positive 2. So here we go. So now we do, right, parentheses, exponents, multiplication, division, and then addition, subtraction. So multiplication is next, 2 times 2. That's going to make 4, and then the addition, 4 plus 3 makes 7. So for the next row, we're going to replace the x with a 0. So here we go. The x now becomes a 0 and do the same thing. Parentheses, grouping symbols, the absolute value part first. So 0 minus 1 just makes negative 1. Absolute value of negative 1 makes a positive 1. 2 times 1 is 2. Plus 3 makes 5. Now we're going to replace the value for the x with a 1. Here we go. 1 minus 1 is 0. 2 times 0 is 0. Plus 3 makes 3. Now replace the x with a 2. Boom there. And then 2 minus 1 is 1. Absolute value of 1 is still 1. 2 times 1 is 2. Plus 3 makes 5. Now the x is going to be replaced with a 3. Here we go. 3 minus 1 for the grouping symbols. Absolute value of 2 makes 2. 2 times 2 is 4. Plus 3 makes 7. Now that we have our table of values filled out, now we can plot points. Negative 1, 7, negative 1, 7, 0, 5, 0, 5, 1, 3, 1, 3, 2, 5, 2, 5, and 3, 7 goes there. And now connecting all the dots, boom, looks like that. So you can see that this makes a V shape. And this is going to have a like a vertex right in here. And that's where it goes from, going down to going up. And it can be vice versa to where it's, starting down here, going up, and then back down. And that point there where it kind of switches directions, that's called a vertex. So when we talk about graphing by transformations or shifts, there is a confusing piece that tends to throw people for a loop. So normally when we think of adding things, so like when we're thinking about adding and subtracting positives and negatives, we think of adding as moving to the right and subtracting as moving to the left. That is not always the case. So here's that confusing piece, and this is why it works the way it does. So here we go. So let's pretend scenario here that you're walking 2 feet per second. So here's what your equation would look like. Your distance is 2 feet per second. T is going to be seconds right there. And so our graph, right, you're starting at 0 and then 2 feet, 1 second, 2 feet, 1 second, 2 feet, 1 second. So your slope is 2. So up 2 over 1. Okay, so that's you. You're the red one. Now let's pretend that there's somebody else and they're going to get a 3-second head start. So here we go. So we're going to add 3 seconds to their time. The T is time, remember, right? So we're going to add 3 seconds to their time. So in these parentheses here, that we're thinking time. So now let's go back to the graph now, right? So you're starting here at time 0. Well, 3 seconds before is going to be to the left of where you start. So they're going to start to the left 3. So they're going to start here and still walk 2 feet per second. Okay, so even though we added 3 here, it moves to the left. So again, normally we think it moves to the right. Okay, let's pretend that there is another person. Here we go. So this person is going to leave 5 seconds after you, and they're going to start 4 feet ahead of you. Okay, so let's look at their equation here. So the distance equals, they're still walking 2 feet per second. Now their seconds here, right? 5 seconds after, so they are losing 5 seconds. So boom, it's a minus 5 there. And then 4 feet ahead, well, you're going to take your distance and just add 4 to it. So it looks like that. Now let's go to the graph. right? 5 seconds after, well, they're going to lose 5 seconds. So they're going to start 5 seconds after. So that's going to be shifted to the right 5. And then they're going to get a 4-foot head start. So instead of starting at 0 right on the x-axis, they're going to start here at 4 feet. So they're actually going to move up 4. And so they're going to start right there. Okay, so that's the confusing piece right here. So when it's in the parentheses, or when we get to the absolute value symbol, when you see a +3 here, it means left 3. When you see a -5 with the parentheses or the absolute value, it means right 5. This is still an up 4, because remember that was a 4 feet ahead there. So that's the confusing piece of why when you have a plus, it's going to go left, and a minus is right, but that only is when it's in the parentheses. When it's not in the parentheses, like this 4 feet head start there, it moves regular up 4, or if you had a -4, it'd move down 4. So before we get into the graphing absolute values, we are going to do a quick review for graphing lines. So this does take the point slope form, this f of x equals -2, x plus 3 plus 1. So when we go to graph these, we want to start with a point. The x1, y1 is where we'll start. So that's going to be a -3, +1 for the starting point that we do. Now, remember from earlier in the video, whenever we see a +3 there, it means it happened 3 seconds earlier or before. So that's going to be to the left 3. So again, similar to that walking example that we did. The other way that people choose to think of it is that, well, if that's a plus, just go left or pretend it's a minus. And why do they think that? Well, simple. Here you go, right? So this is x minus x1. So this is going to be x minus a -3. And that's how you get the +3 being a -3 here. Now, after you have your first point there, now it's time to apply the slope. So we're just going to go down 2, right? -2 and over 1. And there's our line. So we normally draw it that way, and then we go back and draw it the other way as well. Now we're going to go ahead and pivot to graphing absolute value. So this is the exact same function, except instead of parentheses, we have an absolute value symbol here. So the process is going to be super duper similar. The only thing we're going to change is the shape of the graph, but we're still going to start with our initial point. So that's going to be a -3, 1. So the opposite of whatever's with the x in the grouping symbols, and then a +1 just goes up 1 there. So again, if you want to think like walking, like this person got a 3-second head start. So 3 seconds before is going to be to the left of 0. Okay. Now, after we have that point, it's also called the vertex. Now we go ahead and apply, it's a slope type idea. It's not exactly slope because slope only goes with actual lines. Well, this is an absolute value. So we're making the shape that's similar to like a V, or in this case, it will be an upside down V. But check it out. Here we go. So here we go. So we're going to think this is going to go down 2, and then we're going to go over 1. And there's half of our V. Now, how do you make the other half of the V? We'll just mirror image it, right? So instead of going to the right one, go to the left one, and boom, there's the other half of the V. And again, this point right here is called a vertex, and that's where it shifts from going up to going down. Have you go ahead and try this one out on your own, pause the video, then come on back and see how you did. So here we go. We have f of x equals 3, absolute value of x minus 4 minus 2. So we do need to find that vertex or first point first, right? So that's going to be right there. And again, it's going to be the opposite of whatever is with x in the grouping symbols. Or you can think this person left, like if you're thinking the walking, the race, that person left 4 seconds after. So that's going to be to the right. After is on this side of 0, right? So 4 seconds after, and then 2 feet behind, right? So that would be there. So again, that's how you find the vertex there, the opposite of this for the x value, and then this is your y value. And then now we do that slope type idea. It's not exactly slope, but it's similar, right? So we're going to go up 3 because of the 3 here, and then we're going to go over 1, and that's going to give us half of our V, and then for the other half, we're just going to do the mirror image on the other side there. So quick wrap up here. Make sure and get this in your formula section of your notebook. Again, the last like 5 to 10 pages of your notebook should be for all your formulas. So for graphing, here's the vertex form for a absolute value, right? A, that's that slope type idea. So you're going to go up that many and then over both directions 1, and that will make your V. And that's after you find your coordinate point for your vertex there, right? So you're going to go up A and then over 1 for that. So start with your vertex right there, and it's the opposite of whatever's next to the X in the grouping symbols or the absolute value symbols. And that's similar to like when we had the point slope form, right? This one here would be the same thing. Start at the X1, Y1. Here we just call it HK instead. So x1, y1, it's still the opposite of whatever this value is. That's where you start, and then you do the slope on this one here. And if it's a whole number, you're literally going to go up a and over 1. So the only difference between this one and this one is that this one's going to make a line, and this one's going to make a V, and the only thing that changed is we went from absolute value to parentheses or vice versa.